All right, page 77. I'm going to give you one more example, and then I will send you some stuff to work with via email. So page 77, a bullet is fired vertically upward with a muzzle velocity of 250 meters per second. How high does it go? How long does it take to reach max height? And how long is it in flight? So, do what Galileo says. We're going to draw a picture. Bullet goes up, bullet comes down. Has an initial velocity of 250 meters per second. We'll divide it into two events, event 1, event 2. Velocity at this point equals 0. All right, so my first question, how high does it go? Event 1. VI, VF, A, S, T. Initial velocity, 250 meters per second. Final velocity is 0. A is negative 9.8. Remember, we're doing metric now, and that vector is opposing this one, yeah? The question is, how high does it go? So that's the question, displacement. Time is the odd man out. So our magic formula, looking on our cheat sheets, we see that displacement equals final velocity squared minus initial velocity squared over 2 times the acceleration equals 0 squared minus 250 squared over 2 times negative 9.8. 250 squared over a negative 19.6. Negative divided by a negative is a positive. And I have 3,188.776. And that is displacement, so that would be meters. Second question is, how long does it take to reach its maximum height? That still would be event 1. $250, 0, negative 9.8. And that's the question. So displacement is the odd man out. Looking on the cheat sheet, displacement's the odd man out. Magic formula for T. T equals VF minus VI over A. 0 minus 250 over negative 9.8. $25.51. And that's time, so that would be seconds. Now, in this problem, we see that it's idealized. For those of you who are familiar with firearms and shooting, you see that these aren't entirely realistic scenarios, because for the purposes of instruction, they take out the factor of wind resistance. But nevertheless, that would be how it would work. If we were shooting a bullet on the moon, that's how it would work. All right, now the final question is, how much time is it in flight? Well, now that we know that it's going to be the same amount of time going up as it takes to come back down, all we have to do is multiply times 2. And we get 51.02 seconds. One last thing though, even with air resistance, the thing we need to keep in mind, this is for safety's sake, the thing that we need to keep in mind with bullets is that they got a pointy end and a roundy end, and they go this way. And when they go down the barrel, they spiral so that they can stay pointy end forward. And that's why it's not a good idea to shoot bullets into the air, because they lose some velocity, but not all of it. And when they come back down, yes, they cause damage. So don't be shooting bullets into the air. There's your safety tip for the day. All right, so now I will be sending you some problems to work out with at home. I want you to take a crack at these. I'll give you a day or two to play with them, and then I will send you the solutions and the how-tos to go with them. All right, so that takes care of that.